So, system block diagram solution. The marking scheme: give a comprehensive design specification and provide more circuit details for 5 or more different subsystems. You need at least 2 system block diagram solutions, each containing at least 5 blocks. If you don't have 5 blocks, you are not getting into the top mark band. Be aware, the more blocks, the longer your work will take. So although you could have 8 or 9 blocks, you will be making more work but not getting any more marks. Yeah, I can see that somebody might go up to 6, possibly 7, but beyond that, you have to test every single block. And if it takes you 30, 40, 50 minutes to test a block, that's that much extra work per additional block over the 5. And 5 would appear to be the exam board's cutoff point, because that's what they keep referring to, like down here, 5 or more. So, it's up to you. Be aware of time. Each SBD should have a written description below explaining how the system works, should be labelled to show input, process, output. Compare the advantages and disadvantages of each system in the comparison to the specification, and draw out your final SBD with modifications and explain your choice. So, it's a new section, system development, so I need a nice title there. And we're doing the system block diagram solution, so there's our subheading. This is the example taken from the exemplar material. He's stated that he's tested it on Control Studio. This is his first idea. Here is his block diagram, and here is his explanation of how the system works. Now, in reality, there was no feedback from the exam board saying whether this was good or bad. So the stuff that I'm going to say now is my opinion on how it could be made better. He's listed his advantages. He's listed his disadvantages. So, SBD itself and the explanation are okay, but I do think the explanation could use a little more detail and technical terminology. Reference to the electronic signal within the circuit would be a bonus. What they're looking at, when you get to the evaluations later on, they want to see that you've actually said the electronic signal from this should be an astable signal, digital, going from 0, 1, 0, 1 at a set period of time. The electronic signal from this should be, and then this is going to, when this has 2 logic inputs that are high, this will be a logic output that's high, and they want you to talk about how it moves between the boxes. Now, I think that's easier if you actually say, this is an input, this is an input, these are process, this is an output, this is an output. It just makes it easy to put the text, I think. So, I would therefore change the start of the explanation. So he put, when I get a byte, the rod moves, the tilt switch operates, which allows the pulses to pass through the AND gate. Yeah, don't like it. I would put, when I get a byte in the rod, when I get a byte, the rod moves. So a suitable input would be a tilt switch that can sense the movement. When the rod moves the tilt switch, it will give a high enough voltage to act as a logic high for the input of the AND gate. So we're using technical terminology, we're talking about signals going from one box to another, and I would use that and describe each box and how. So I've done that one. The next one I would do is I would talk about the pulse generator, and then I would talk about the AND gate and follow the system through. Personally, I think his biggest area for improvements is his advantages and disadvantages. The whole point about writing a specification is that you need to satisfy the points within the specification. So surely that's what should be in the advantages and disadvantages section. They should also all be PEA, point evidence analysis. They should refer back to specification. Fairly complicated and quite expensive to build. What on earth has that been based on? It might be complicated, but where? How do we know this? What's it based on? And same goes to the cost. He also hasn't actually justified the statement. So I would have said, although this circuit will successfully satisfy the specification, I am concerned that I have one transducer driver powering both the buzzer and the LED. These components have very different voltage and current requirements, so I would need to investigate this further if I choose to develop this circuit. So I'd actually be pulling something either technical or related to the specification. Got to do it twice, at least 2, and then you need to do a comparison. So you should have for each one your block diagram, your explanation of how it works, your advantages, your disadvantages, and they should be PEA and they should refer back to your specification where possible. So having done the two, really the best way to select one is to do a comparison. So here's my specification points. I've just copied the one from the previous page. Obviously you would have a proper set of specification points. And then literally SBD1. Does it do it? Does it do it well? Does it do it badly? Same for SBD2. And then having gone down and analyze whether or not one of them satisfies the specification points more than the other, you would then write a statement at the bottom saying, I am selecting SBD, whatever number, or I am combining elements of SBD1 and SBD2 to develop my chosen system. At which point you're going to have your inputs, outputs, processes labeled. It is very important you do that on this one. If you haven't done it on the previous ones, you must do it on this one, because that will get you marks actually further through. It's either in the third or the fourth section. It refers to, have you got a system block diagram that has got the input, the process and the output labeled. So do it now. Don't lose those marks for later. And hopefully that will move you on to the next stage. If you feel you've changed it significantly, you should write a new system explanation.